Okay, so now that we have the idea of hopefully determining charge, okay, we're going to go on into naming. And this whole idea of charge and naming and writing formulas is all going to jive together, and you will get good at it, basically. So the next thing I want you to do then, okay, is you should write down VodCast 9-2 in your notes, and then you should title it Naming Binary Compounds. So that should be the next thing, and if you go ahead and start a new page, that's fine. Or if you just continue right from your last notes are, but make sure you make this very noticeable so I can find it easily when I look through your notes. Okay, so I'm going to just review a little bit, and I know we've gone through this, but just make sure we're all starting on the same page here. Writing element symbols, okay? Make sure that we note that there's a maximum of 2 symbols for each element, okay? And elements with 2 letters in the symbol, the first is always capitalized, the second is always lowercase. People who make N's like this, okay, that is really incorrect. If it's an N and it's capital, it should be N, all right? So, just so we're all on the same page, manganese, Mn, this Mn is manganese, this Mn is Minnesota, okay? This Mg is magnesium, Co is cobalt, Co, like this, is carbon monoxide. And particularly in this chapter, okay, we really need to make sure we are writing symbols correctly, okay? And then the other thing is a lot of elements use their Latin name, so okay, you have to pay attention to that, because once in a while, and even I get caught in doing this, we want to write phosphorus as P, which phosphorus is P, but then we want to write potassium as P also, and potassium is K, so we just got to be careful with that. Okay? Now, what we're going to get into is naming, okay? And all naming is done by the International Union of Pure and Applied Chemistry, or IUPAC. So don't blame me for the naming rules, blame these people, because they are the ones that came up with it. And then the last thing is, you need to remember that with all of these, we're still doing the same things that we were doing in the last chapter, is all elements are trying to reach an octet configuration, and they can combine with any number of elements to do so. So we're going to kind of go away from worrying about the octet configuration, but you need to keep in the back of your mind that that's really what we're doing. So what we are doing is what is called nomenclature. Okay? Nomenclature is the fancy word for naming. So you want to write that down. Okay? And what we're going to start with here is very simple, the simplest step, kind of the first step in naming, and that would be with binary compounds. Okay? And we've already defined the word binary. Okay? And binary compounds have 2 different kinds of atoms. Okay? And when we deal with this, one is a cation, which we know is a positive charge. The other is an anion, which we know is a negative charge. And that's all you have. You have one positive charge and you have one negative charge. Okay? Now, in naming cations, okay, that's our positively charged atom. These are basically going to be metals. Okay, so you can look at the stair-step line in the periodic table, and it's basically going to be anything that's a metal. And the one thing with these is they don't change much. Okay, so if you're going to name a metal, it remains the name of the metal, basically. So if I have potassium, okay, potassium becomes a plus charge, then it's called a potassium ion. Okay, strontium, okay, if Sr is a 2+, then it's a strontium ion, and then Fe, okay, and you got to pay attention, is a ferric ion or an iron ion. Okay, and we'll talk about that. That's kind of our second day of naming systems. Okay, now anions those are slightly different as far as their naming goes. We don't change metals. With anions, those are negatively charged ions. Those are basically going to be our nonmetals. And what we're going to do is we're going to add an IDE ending to these. Okay, so one thing I could back up and say is with these binary compounds, basically what we're doing is bonding a metal to a nonmetal, which, if you recall, is our ionic bond. Sorry, my eye got a little longer. Okay, but that's our ionic bond. Excuse me. And with nonmetals, what we're going to do is we're going to add an IDE ending to the end of the name. You, quite honestly, are very familiar with this. Okay, so if I have chlorine and it becomes a -1 ion, instead of calling it chlorine, we're going to call it chloride. Oxygen, with its -2 charge, is going to become oxide. Phosphorus, when it's a -3 charge, will be phosphide. Okay, and we want to, sometimes that becomes a little tricky. We actually, if you notice, we go all the way back to here when we put the IDE ending right there. We don't call it phosphoride, it's just phosphide. And that's basically what you do with these, okay? If I have sulfur as a 2-, what do you suppose that becomes? And you probably wrote down sulfide. Okay, so in naming these, okay, a couple things to remember. Metals are always written first in a compound. So metals come before nonmetals. And then the other way to look at it is cations, or positive charges, always come before anions or negative charges. So how does this work? Okay, well, you're just going to be given 2 elements. Okay, I have Mg and S. And this is where going to the oxidation numbers comes in handy. So if you go to your periodic table, and I kind of took a picture of your particular periodic table. If you don't have your colored periodic table out yet, take it out. Pause the video, get it out. Okay, and we look at magnesium, and right in there, okay, you see that magnesium has a +2 charge. Okay, and you'll notice, and I should have threw this up when we talked oxidation numbers, but you'll see all of these, all the way down, are +2 charges, and that's all they can be. All of these group 1 elements are all +1 charges, and that's all that they can be. Okay, so those are things to keep in mind. Okay, so oops. Ooh. So when I go to magnesium, magnesium is a +2 charge. Well, by rules of oxidation and reduction, or oxidation numbers, excuse me, okay, if I have sulfur, you should pretty much be able to bet that sulfur should be a -2 charge. So I'm going to write the formula MgS. And that's all part of this chapter. You have to be able to write the formula. And then we also have to name this. So MgS we want to name. And that name is going to be magnesium sulfide. Okay? And that's it. That's basically how we name these. Okay? So we're just going to do a bunch here. So if I give you the element aluminum, and I say that's going to be bonded to the element beryllium. Because these are just binary, you look at their primary charges. So when you go to this periodic table, you see, okay, aluminum, that's a +3. Now, you will also see beryllium, and you'll have to look on your sheet. I'm sorry that doesn't come out here very well. Beryllium can be multiple charges. But because we're binary, it's going to be the primary charge of the group. And the primary charge of the group is -2. And aluminum is +3. So when I look at these two, the formula that I want to write, and I'd like you to go ahead and write the correct formula. And this goes back to the last chapter as well. The correct formula is Al2Te3. Now we want to name this compound. So that's the next step that we're doing besides writing the formula. And this would be aluminum and then tellurium, we put an IDE ending on it, becomes telluride. Telluride. Okay? And that's what we're going to stick with, okay? So let's do one more. Let's give you potassium and phosphorus. Okay, so first thing, look up the charges and write them down. And charges always go up here. So potassium is +1, phosphorus is -3. Okay, then go ahead and write the formula. So our formula is K3P, and then name it. I'm sorry, my smartboard is acting up again. That's potassium. Potassium phosphide. Okay, the other thing that I'll do to you is just give you two names. Okay, so next thing I might do is say, okay, tell me the name of a compound that would form between barium and fluorine. So then what you would need to do is say, go up and look up, okay, barium, that's Ba, fluorine, F, and then you need to look up their charges. Barium is a group 2 element, so it's +2. Fluorine is a group 17 element, and its charge is always -1, according to our oxidation rules. And then we'd want to write the correct formula. And then we'd want to name it. And that would be barium fluoride. And that's all there is to the very first worksheet that you're going to do. Okay? It's very straightforward. Okay? You're going to write formulas and you are going to name compounds. So, the first worksheet that you're now going to do is naming binary compounds. Okay? And then you can also do the reading guide associated with this. Okay?